Yes, sir. You are
Audible, sir.
Right. So in our last session, I think we are discussing about the recursion. We need to see few more examples related to this recursion. Let us see how you can work with this remaining around some 2 or 3 examples are there. Let us finish that. The next example is, sir, very important. Sir, I need to generate, okay, I need to generate all possible permutations of a given string. I need to generate all permutations of a given string. Sir, you know very well, for example, if the given string is a, if the given string is a, so what are the permutations that you are going to get? Only one, right? Okay, only one will be there here. Next, suppose if we are taking the string called AB, what are the permutations we are going to get? I mean, what are the combinations that you are going to get? AB and then BA, all possible combinations. If you take ABC, then you are going to get ABC is the first combination. Then A will be there as it is. CB is going to be reversed. Then next combination BAC will become one combination and BCA will become another combination. Then sir C, okay, AB will become one combination and CBA will become another combination. There is one standard formula is there. If a string is having n characters, then n factorial combinations you are going to get. So here we have only one string is there, 1 factorial is 1. Here we have 2 characters are there, 2 factorial is nothing but 2. So here we have 3 characters are there, 3 factorial is nothing but we are going to get a 6. Sir, the application is very simple. How you can able to write a recursive process for this, I will explain. Okay, I will explain how you are going to take. Sir, it is a very simple, just like a recursion tree we need to imagine. Recursion tree we need to imagine so that you can able to understand how these combinations are going to be generated. First, I will write the code, then I will explain the process. Okay, so def, I am taking permutations. This is nothing but the function which is taking 2 parameters. One is nothing but the string, another one is nothing but the answer. Okay, this is nothing but the function. Sir, at the very beginning, I am going to call permutations function by passing a string as a AB. Okay, or let me take ABC, and my answer is nothing but initially empty. These 2 values I am going to pass. Now what will happen? Sir, for each I value in the range of, for each I value, okay, in the range of 0 to length of the string, 0 to length of the string. How many characters are there in the string? Those many times this loop is going to work. Every time we are going to call permutations of by passing s colon I. This is one argument. For this we are attaching I plus 1 to ending. This is one argument. Another argument is nothing but answer plus s of I. A simple code we have written, sir. Beyond that, nothing. Sir, anyway, base condition is not yet calculated. I will show you how you can able to write base condition. Listen carefully. First time, I am going to pass the string as a ABC. Listen carefully how I am going to draw this tree. So the first whatever we have given is nothing but the input is nothing but ABC and result is nothing but empty string. Now, for I in the range of 0 to, how many characters are there in the string? We have 3 characters are there. That's why this process is going to be repeated for how many times? 3 times. This is nothing but when I is equal to 0, and this is nothing but when I is equal to 1, and this is nothing but when I is equal to 2. Sir, when I is equal to 0, what we are doing? S of, observe carefully, from beginning location to 0th character we are selecting, plus from 0 plus 1, 0 plus 1, that means 1 to rest of the characters. Sir, starting from 0 to 0, are you getting any character? No. we are not going to get any character. Then S of 1 to remaining. That means what? First character onwards. So means what? This is 0th character. This is first character, second character. That means we will get a BC. Now here you are going to get BC as the string. This is the first argument. Comma. What is the answer? Initially answer is empty. For that answer, we are adding S of 0. That is nothing but A we are adding. Initially it is empty. Empty string plus A string concatenation we are going to get. The result will become BC comma A. Sir, is it a function or not? Yes. Again it will work. How many times? How many characters are there in the string? 2 characters. That's why it will again call I is equal to 0. For I is equal to 1, it will call because it is a recursion. Because it is a recursion. Again, it is going to be called. Sir, this same process, okay, this same process is going to be repeated for I is equal to 1 or not? Yes. Sir, in this case, what will happen? Sir, S of colon I value. What is I value? Here I value is equal to 1. So colon 1 plus S of 1 plus 1. That means 2 to colon ending. S of colon 1 means what? So we will get only 0th location plus 2 from 2 to rest of the characters C. What is the concatenation of these two strings? We are going to get AC. And what will be your answer? Answer is already empty. Empty plus S of I. I value is what? 1. So in first location, which character we have? BC. Again, it will be repeated for 2 times. When I is equal to 0, when I is equal to 1. Because the string is AC. So here what will happen? You can imagine. Sir, we are giving I value as a 2. That means S of colon 2 plus S of 3 colon. Okay. So what will happen? What will happen? S of colon 2 means what? Up to. So first location it is going to give, which is nothing but AB. Comma, answer plus. Answer is empty. Empty plus I is equal to 2. In second location we have C. Again it will be repeated for I is equal to 1 and it will be, sorry, I is equal to 0 and it will be repeated for I is equal to 1. Sir, if you see at the top level, every time what we are doing, we are selecting the first character and we are putting into the answer. In the second case, we are selecting second character and we are putting into the answer. In the third case, we are selecting third character and we are putting into the answer. So every time when you are selecting the data, we are ignoring, we are deleting that data from the string. Sir, how you can delete? Because this concatenation I performed. So up to that location we are fetching. From that next location we are going to fetch. So that new string it is going to give every time. Okay. Sir, now this process has to be repeated one more time. I will show you how it is going to work. But before that, can you please confirm up to this tree? Do you have any doubts?
Sir, I is equal to 2 means it will take a B value, right? First
No, C value.
0, 1, 2.
No. You are talking about, yeah. So S of what we have here. So S of, so colon 2.
Yes. 0
plus S of 3 colon. Anyway, 3 colon, we don't have any characters.
Oh, yes.
So here we will get 0th location and first location. So
yes.
we are getting only AB. Okay.
Okay.
Sir, I request everyone to please confirm how we have framed this tree diagram. Is it clear? Sir, nothing is there here. Please respond, friends, because
yes, sir.
The only thing I need is from your side, you need to get whether you are getting the concept or not. Otherwise, so if you want, I will explain directly. Okay, total problem. At last, we will discuss for queries. Is it okay for you people?
Yes, sir. Clear.
Yes, sir.
Right.
Sir, now
what
after this, when I goes to 0, 1, 0, 1, 0, 1, now like it will not go ahead. The loop will
whatever,
stop.
yeah, whatever process we have done here, same process will be repeated.
So please show for I goes to 0.
Yeah, I will show you, sir. Just up to this, I asked the doubt. That's all.
Okay, sir.
Yeah. So here you can see This is the first call, this is the second call, this is the third call, because we have in a loop. Sir, again we are calling a function, right? That's why what will happen? This process will be repeated. When I is equal to 0, my string is BC. From this, we are selecting the element which is located in 0th location. How the formula? S of colon, we are going to take 0 plus S of colon 0 plus 1, 1 to colon. S of this one won't give any string. 1 to next character, 0, 1. That means C. So your C will be there in your input. And whatever character available at 0th location, that is B, I am adding to the answer. In answer, already A is there. For that, we are adding. So in this case, what will happen? I is equal to 1. That means S of colon 1 plus S of 2 colon. That means what? So up to 0th location. 0th location is nothing but B. So that will be there here. And here it won't return anything. And I is equal to 1, right? In second location, first location, we have C. That C will be added to the ending. You can see we are going to get AC. We are getting AC. So I will write this clearly. 1 second. So B comma, we are getting AC like this. Then here what will happen? Again, when I is equal to 0. So same process, right? The first character, okay, the first character will be moved to the this one. So that you will get C and then BA. And here second character will be, first character will be as it is available. Second character will be attached. That means PC. In this case, sir, the first character is going to be attached. Second character will be same. And in this case, first character will be same. The second character will be attached. Sir, is the length is equal to what? 0. Sir, again it will be repeated for I is equal to 0 because we have only one element is there. Again I is equal to 0. 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 Why it is going to work only one time? Because the string contains only one character. Sir, next what will happen? Next what will happen? Sir, we have to select, again apply this process. S of, when I is equal to 0, so colon 0. That means no character will be selected, plus S of 1. 1 means, sorry, 0 plus 1 means 1. From 1 to remaining, no character. Because the data is available only in 0th location. So this S will become empty. And that C will be added here because of this formula. Okay. So we will get ABC. And here we will get empty string and we will get ACB. So here we will get empty string and we will get BAC. So and here we will get empty string and we are getting BCA. So here we are getting empty string and we are getting CAB. And here we are getting empty string and we will get CBA. If you see here, ABC is the first permutation, I mean first combination, ACB. And starting with B, BAC we got, BCA we got. And third CAB we got, CBA we got. Have you observed? Sir, we have to stop this process here. What is the base condition? If you observe the string, when its length is 0, we can stop, right? I'm going to write base condition now. So what is the base condition? When size is equal to, okay, when size is equal to 0, we are going to stop the process. Let us see what will happen. If the length of the string, when it becomes 0, then just we are going to print the answer because there only we got the answer, right? Then we are going to return. And this process will be continued. This process will be continued. Sir, is it possible to generate these kind of things by using loops? This much easiness you won't get. If you want, let me run this code and check really whether we are getting output or not. You can see in the same order we got, right? ABC, ACB, BAC, BCA, CAB, CBA. Sir, can you please add one more character? No problem. 4 means what? You are going to get a 24 combinations. You will get 24 combinations. Okay. Sir, I want to take 5 characters. So 120 combinations you will get. 120 combinations because 5 factorial is 120. 120 combinations. If you see the tree diagram.
Factorial, it is giving.
Uh,
According to the factorial, it is giving that number of combinations.
yeah, you know, right? Mathematical formula that is. Okay. So this is the way how you can able to generate
The
combination.
code is simple only, but we have to trace that answer, sir.
Yes. So I think everyone got clarity how
Yes,
it is
sir.
going to work.
Sir,
Can you
I
please
have
confirm?
got that clarity, but we have to see that video 1 second, 1 second, 1 or 2 times, sir. After that.
Yeah. You have to practice by seeing
Yes,
the
sir. Practice. We have to practice, sir.
And
Yeah.
one
The
thing
pen and paper and practice that how it is coming, and in future it is we never forgot means we have to practice that 2 or 3 times, 5 times also, sir.
Yes. I will share this image also. I have taken the screenshot.
So, sir,
I
yeah.
will share this image also so that you can try to write this in a A4 paper and then try to take one small input with the
Yes,
size
sir.
3 and take input with the size 4 and try to trace it by taking
Yes,
the
sir.
A4 paper in the landscape. Try to take ABC and draw this tree. Then you people can get very clear clarity. You won't forget this. Okay. I request everyone to please confirm. Is this concept is clear? Please confirm.
Yes, sir. Yes, sir. Thank you,
Yes, sir.
sir. Nice
Yes, sir.
example you have explained it.
Thank you.
Sir, can we add in this counter means how much time it will execute this?
Time or how many times?
Count means if we can put count is equal to 0 and count is equal.
Yeah, we can do that. We can do that. How
Means
you can do that? Do you want to
uh,
see? So I
under
think
the if
Raj
state.
is having always a doubt on me. Let us show proof for him. Huh? Let us
Sir,
take count is equal to 0 initially. Okay. This is from main method I am writing. Then where you will get answer here only, right? So here I am taking C is equal to C plus 1. So at the last term, I will print the total number of combinations. Let us run this code. Sir, here you can see there is some mistake. I am deleting the diagram, sir. Since it is a local variable, right? So here we are using it as a local variable, but here it is different. That's why let us define global keyword. Now C will act as a global variable. Now see what will happen. Sir, how many combinations we got? 6. Now let us add one more character. We are getting 24 combinations. Let us add one more character. 120 combination. Let us add one more character. 720 combinations. E, F, G, H. How many combinations? 40,320 combinations you are going to get. Even you can't imagine. Right. Sir, clear? Your doubt got clarified, right?
Yes. And sir, we have this inbuilt function also in iterator module.
Yeah. We can use that also.
Yes. Explicitly code we have to write in that.
Yeah.
Yes. And regarding this, we have taken a string and means any iterable. We can take a list and tuple also. We can show.
Yeah. Same concept
Same.
will come.
Yes. Okay. That's it.
You can do that. Sir, I request everyone to please confirm is the concept is clear for you people.
Yes, sir. Yes, sir.
Yes, sir.
Right. Now, sir, my next question is, so I want to find subsets of the given string. Okay, next example is nothing but subsets of the given string. Same kind of a program, sir. Suppose if your input is A, you will have two subsets. You will have two subsets. Okay, so one is nothing but empty, another one is nothing but A. If you have AB, another, how many subsets you are going to get? Empty, and A is nothing but one subset, B is nothing but one subset, AB is nothing but another subset. If you have ABC, so you are going to get empty string. A is one subset, B is one subset, AB is one subset, then I think AC is one subset. Okay, then we have BC is nothing but one subset, BC is nothing but one subset. Okay, any other? AB, AC, BC. Okay, so then we have A.
One more. C, you have missed, sir.
Yeah, C is another subset. Okay, like we have. Sir, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Sir, have you observed if you have n characters are there in the string, So you will have n power 2 power n subsets. If n is equal to 1, 2 power 1, that means two combinations, two subsets. If n is equal to 2, 2 square, 4 subsets you are going to get. If n is equal to 3, so you are going to get 2 power 3, 8 subsets you are going to get. Sir, it is something like same like previous program, whatever we have done. But here, what we have done, we have taken the string and we are selecting the character from the string and we are putting into the answer. Here also, same thing we are going to do. But the difference is nothing but with including one character, one combination you will get, excluding that character, we will get one combination. For example, if the given string is AB, what we are going to do is we will have two options. So first option is nothing but consider I'm going to start with index 0. So we are going to select the A, that is one combination. We are not selecting the A, that is one combination. If you select A, then what will happen? You are going to get AB. Sir, if you are not selecting A, then what will happen? We are going to get only B. Okay, so like that we are going to see. Here we are going to talk about B. If you select B, then what will happen? You will get AB. If you are not selecting B, then you will get A. Like we are going to get all the combinations. Anyway, I will show you how it is going to work. Like this, here we have two processes are there. So anyway, I will write code for that so that you can understand. I will do the modifications. So I'm going to call subsets by passing ABC as the input, and answer is nothing but empty. But in addition to that, we are going to pass one more input, which is nothing but the starting index. So subsets, which is having a string yes, and the answer is there, we have index value is there. I will write the base condition later. So subsets of, I am taking the string. So I will select that character and I will add that character into the answer. Okay. Next time what will happen? I'm going to go for the next character index +1. In the second case, what we are going to do? We are not selecting that value. Two combinations we are going to get. Let us write code for this so that you can understand very well. Sir, now consider my input string is nothing but ABC. My output is empty and index value is nothing but 0, right? So here we have two options are there. What is the first option? We are selecting the data which is available in 0th location and we are adding to the result. So your input will be same. Okay, your input is nothing but the same. We are going to get ABC. And answer will become what? In this case, we are selecting the 0th location. If you select the 0th location, already answer is empty. If you select only 0th location character, we will get A. And index +1, which will become 1. In the second case, what we are doing? Sir, original string we are not altering. It will be same. So here we are not selecting the 0th location. That means what? You will get empty string only. And index value is +1. In this case, again, you will get two places. Sir, index value is 1. That's why you are going to get two choices because two calls are there. In the first call, from the string, we are selecting the value located at the first location. Your input is ABC. The character which is located at first location is nothing but B. We will select this and we are appending to the A. So that what will happen? We will get AB and your index value will become index +1, that is 2. And here we are going to get the original string as it is. And we are not selecting the character located at. Sir, I request everyone to please switch off video mode. So here we are selecting B here. We are not selecting B here. So that your input will become only A. And index got incremented. Here, sir, ABC will be as it is. We are selecting the value which is available at first location. So B, that will be added to the result and your index value will be incremented. And in this case, ABC will be there. You are not selecting the first value. That means it will be same as it is, empty string and then index value is 2. Sir, now again, index value we are going to increment by 1 unit. So that what will happen? Again, two choices we will get, two choices we will get, two choices we will get, two choices. What is this choice? So we will keep ABC as it is, and we are going to select the character at second location 0, 1, 2. If you select, what will happen? You will get ABC and your index will become 3. In the second case, if you are not selecting, then we will get ABC and then AB, and that result will become 3. And in this case, I am writing here. So we will get ABC, and the next string is nothing but what? We are not selecting the data available at second location. So we will get A, and then index is 3. So in this case, AB, we are selecting this, you will get AC. So here we are getting ABC, and we are not selecting means we will get only A. So in this case, ABC, and we are selecting the character at second location, we will get BC comma 3. So in the other hand, ABC, and then we will get B and then 3. So in this case, ABC, and we are selecting the character at second location, you will get a C, and then index is 3. So here ABC, we are not selecting anything, and index will become 3. Sir, almost we reach to the output, right? If you see, we got ABC, we got AB, we got AC, we got A, and we got BC, we got B, and we got C, and we got empty set also. Almost we came to the ending. Okay, sir, what is answer? Answer is nothing but our result. There only we are pushing the data. Now let us see what will happen. Sir, we have to write the base case. When we have to stop here, we reached the base case. How you can consider base case? Initially, my answer is empty. In this case, 1 is the answer length. In this case, 2 answer length. I mean, we can say index value. Sir, index is 0, index is 1, index is 2. When index will become 3, we can stop, right? So if it is equal to the input size, we can stop. That's why the base condition, what I am going to write here is, so if your length of your, if your index value is equal to length of the input symbol, don't take answer length. So because answer length is going to change it. Then what we have to do? Sir, you need to print the answer and then return the control. That's all, sir. Our program completed. Okay. Now we will see how you are going to get this output. Let us cross check. Sir, you can see we got ABC, we got AB. Okay. Then we got AC, then we got A, then we got a BC, and then B, and then C. Sir, almost all the combinations came except this empty. Empty also came, sir, but we are unable to see that. So what I will do is, whenever we are getting empty, I will display null so that we can understand very clear. Here you need to put one more condition, right? So what is that condition? Array, if your answer length, okay, length of your answer, okay, so is equal to 0 means what? I need to print the message saying something like null, right? Otherwise, what I will do? I will print that answer. That's all right. Now you can see. So ABC is the first combination, AB is the second one, AC subset, A is the subset, BC is the subset, B is the subset, C is the subset, at last null is the subset. Like this, we can able to find out sum of subsets, I mean subsets problem. I request everyone to please confirm, is this program is clear for you people? Yes, everyone please respond. Is it clear up to this whatever we covered?
Yes, sir.
Right. So at last, I will end up with one small program. I mean, this particular concept alone. So what is that is nothing but towers of Hanai. The problem is nothing but, so towers of Hanai, towers of Hanai. Sir, it is a small problem. Okay, I think you have seen this problem very well. Here we have some towers are there. Okay, so you need to move. Okay, here we will have some 3 towers will be there like this, or 3 desks will be like this. Sir, you need to consider it is A, it is a B, and it is a C. This is nothing but a source. This is nothing but the destination. So here some towers, I mean some disks will be there. So consider this is 1. The length is nothing but 1. So you have to move one disk at a time. We have certain rules are there. You need to move all the disks which are available in the source to the destination. So here directly you can take the disk here, right? Directly you can able to move. Okay, first disk directly we can able to move. Because we have only one disk is there, that's why there is no problem at all. Suppose consider I have two disks are there. Okay, how I can able to move these two disks? We have certain rules and regulations are there. By following that rules and regulations, so we have to write the code. Okay, so what is the rules and regulations? I will write some rules here. Observe carefully. Sir, rules. Rule number 1. Only one disk moves at a time. You have to move only one disk at a time. Second rule, so no larger disk above smaller disk. So you can't take larger disk above smaller disk. So that means what? Suppose if you want to move the disk from A to C, sir, is it possible to move from directly this one here? No possibility. Because if you move here, what will happen? Next step is nothing but this one. You can't move like that. That's why what is the efficient solution for this? First, this is the first disk and this is the second disk. I will move second disk from here to here. And then I will move first disk from here to here. Okay, and then I will move this second disk from here to here so that I will reach my target. Very simple, right? So here third rule is nothing but only the top disk. Okay, the top disk of the tower can be moved. So suppose if you have like this, sir, I will take this first disk and I will move. No, something like stack. So you have to pop only the topmost element, top of the disk only you have to move. Sir, since here we have one disk, there is no problem. Here we have two disks. Maybe some small steps are required, but we completed. But sir, imagine we have three disks are there. This is the first disk, and this is the second disk, and this is the third disk. Sir, I want to take all these disks into the destination. How you can do, sir? It is highly impossible, right? Okay, it is highly impossible. We have to follow. Okay, so we have to follow certain rules. First, I will move this 3 to ending. So that what will happen? You will get 1, 2 here, and that third disk will be moved to the C. So next, we will move second disk here. Okay, we will move second disk here. So that what will happen? You will get first disk here, and the second disk will be there in B, and the first disk is, third disk is already moved to this temporary. Then what I am going to do is, so like we need to do some process, sir. Anyway, I will explain in the diagram, I mean in the coding, so that you can understand well. But I will show you how this diagram will be. Okay, how this diagram will be. Maybe some animations, something like this, it will be there in the net. I will open. Okay, so towers of Hanai. Okay, animation.
Sir, what is this exactly? I didn't understand. What is Tower of Hanai?
Sir, it is a small problem, sir, what we have. You can see here we have some towers will be there. That means rods. You have to move this particular, it is something like a game. So we
Okay.
have to move at a time one disk only you have to move. And a smaller disk you can't, larger disk you can't place on the top of smaller disk like this. We have some. Okay. So here disks, I'm going to take 3 disks. And I have how many towers are there? 3 towers. So get the solution. You can see. Sir, have you observed here? So here we have, is it going to play? No. So show solution. You can see the first disk got moved here. The second disk got moved to the last, and the first disk moved here. And this first disk came here. And then this disk go to here. and this disk will come here. Okay, next this disk will go here like this. So this will act as a temporary. This will act as a temporary. Okay, so I will take a speed. Now, sir, again I am replaying. Just have a look once. This is the first movement. We are moving to the destination, first disk. Second disk we are taking and we are moving to the temporary. Then from that destination to temporary. From that source to destination. From that temporary to source. From that temporary to destination. From that source to destination. You can see all the three disks reach to their places by moving one disk at a time and by following that rules whatever we have given. So total how many combinations, total how many moves we are going to get? 7. Sir, it is somewhat difficult, sir, somewhat difficult to understand. Okay. We have so many things are there, you can see here. So disks 3 start, you can see like this it is going to move. Tower B, and second disk is going to move to tower C. Then tower B disk is moved to tower C, and tower A is moved to tower B, and this one is moved to tower A, and this one will move to tower B. Here I can say tower B is the destination. Now we will give two values. Okay, we will give two values, two disks. Now you can see. One second. We have two disks are there. This one I explained, right? First top disk, second disk will move to where it is going to move. First, it will move to the B. That means what? For tower C in this example, you can see. So that is moving to tower C. Next, this white color disk is moving to tower B, and then this disk will come here. Only 3 moves. This is the first move, this is the second move, this is the third move. So if you have only one disk is there, okay, if you have only one disk is there, how many moves will be there? Only one move.
move.
That is nothing but it will move from here to here. Sir, it will work for any number of disks. If you take like some six steps, so it will take how many moves we have to take? Around 63 moves we have to take. Sir, it is very difficult to write these kind of solutions by using our normal loops or something like that. But recursion is going to give any very simple solutions. Okay, because this big problem they are going to solve and they will find the solution. So you can see how it is going to come. Whenever you have a time, you try to practice these things. Okay, you watch this video.
Sir, whatever the stacks are available in one tower, in the same appropriate way, we have to move to the another destination. And but to manage that, we need some temporary tower, right?
Yes, that's all.
Okay, means it would be same identical, and in the we can say means top is ascending order, right?
Yeah, definitely. That will be in increasing order.
Yes.
The larger size will be there in that. You can see the kids are playing these kind of
Yes,
games.
I understand.
Yeah, sir, we will write this solution in our recursion, sir. Everyone, can you please confirm is this concept is clear? Is the problem statement is clear?
Yes, sir.
Yes, sir.
You will get shocked by seeing the solution. Okay, I think already you are in shock by seeing these solutions. Now you are going to get more clarity. See, so here I'm going to take a function called something like a towers or something like this, towers. So I have three towers are there, 3 or 2 disks are there. Tower A is there, tower B is there, and a tower C is there. Okay, so otherwise if you want to get confusion, so let us take, okay, let it be C. First we will write the code. So here I am going to take a towers problem. Sir, here number of disks and then source and then temporary and then destination, like this we have. Suppose if your n is equal to 1, n is equal to 1. So directly I am printing the solution saying in a formatted string I will buy. So we have to move the disk 1 from, can you please tell me from which position to, from which variable to which variable you have to move
A to B,
with respect to A and then B and then C? Tell me.
A to B,
A to B or A to C?
A to B.
A to B.
A to C. Sir, please listen. From the diagram, A is the source, B is the auxiliary, temporary, and C is the destination. So if you have only one disk, directly it will move from source to destination. Got it? So the disk is going to move from A to C. Got it? Clear? Everyone,
sir.
please confirm. Is
Sir,
the base condition is clear?
A is a source and B is what you said?
Temporary.
Temporary. Okay.
Otherwise, I will
Okay.
give one thing,
Destination
sir,
will be
for you to.
mentioned in the problem.
Uh-huh.
Destination will be mentioned in the problem.
Sir, we have only 3 towers are there.
Sir, because in the animation B was destination, right? For 3.
No, yeah. In the animation, they have shown like this, but follow my diagram. It can be anything, right? Positions can be anything.
Okay, sir.
So in the diagram, how I explained, directly this one is moved to this one. And here we have taken this as the destination. I will do one thing. So here I am going to change the names. Now, can you please tell me? Source is nothing but A. Temporary is nothing but B. Destination is nothing but C. Now what will happen? It is going to move. Otherwise, here also I will use the variable something like this so that you can understand very clearly. Now you can see, sir, it will move the disk from source to destination, right? This is one solution when n is equal to 1. Suppose if n is not equal to 1, then what will happen? We will call this towers of Hanai problem by passing n minus 1. Okay, and then I'm going to keep source as it is, and then I will change the parameters order, destination, and then I'm going to take some temporary. Okay, so then I will print a formatted message saying I want to move. Okay, I want to move the disk. Okay, I want to move the disk n from so here it will become source. Okay, source to, in the place of destination, what we have temp is there. Okay, we have, yeah, we have destination. We have to move from source to destination, but the position got changed. And here we have to take temp first, and then we have to take a source, and then we have to take a destination. Yes, anyway, I will explain the process. Listen carefully. When we have 2 disks are there, is n value is equal to 2? No. Sir, I am going to redraw the diagram. Here you can imagine this is nothing but what we have. Okay, this is nothing but what we have. This is a destination, this is a source, this is a temporary. We have 2 disks are there. So whatever the process I explained here, the same process will be there here. Listen carefully. Okay, this is disk 1, this is disk 2. Sir, is n is equal to 1? No. Sir, what is the first step? Towers of, again I am calling the same problem by passing n minus 1. So one disk source. Okay, so first we are passing source. Here source is nothing but yes, and we are passing destination. So what is the destination here? T. Destination is nothing but a D, and temporary T we are passing. Okay, listen carefully. Source, destination, temp. Now you can see this particular diagram. So when n is equal to 1, it will call, right? What is going to be happened? Move disk 1. We are going to move the disk 1 from source to destination. Please observe carefully. Source is available at the beginning, destination is available at the ending. It will move the first disk from source to temporary because you can see the positions. So it will move the first disk or second disk. Okay, yeah, first disk. I think they are going to Yeah, they are going to change the numbers. Maybe they are taking this as a first and this as a second. So they are going to move this disk one. No, correct only. Yeah, correct only. So maybe in the problem they are considering this as the first disk and this as the second disk. Okay, we will see. Otherwise, we will change. We are moving the first disk from source to temporary. This is the source, right? From here to temporary, we are going to move. Is it correct? Is this is the first move that we have done? Yes, I am writing in black color. You can see. Sir, once if you move, then what will happen? So this will be gone. This will be gone. Right? This is the first step. So after this one got here and this part got completed. This one completed. Now we have this part, right? So in this part, what is the method call that we have made? N is equal to 2. Source is there here. Temporary is there here. Destination is there here. See, this part got completed. This part I am talking. Now we have to move the disk 2. We have to move the disk 2 from source to destination. Here source is nothing but S and destination is nothing but D. Now we are moving this 2 disk from here to here. Right? Is this process or not? Yes. Once if it is moved, then just I am going to delete this one. Completed, right? So this one got completed. Now we have this pending n minus 1. We are going to call n value is what at this point, starting point 2. 2 minus 1 means 1. So temp. We are taking temp and then source and then destination. What will happen in this case? We are going to take n is equal to 1. Move the disk 1. We are going to move the disk 1 from source to destination. Source is nothing but what? First argument. That is a temp to destination will become last argument, which is nothing but a D. We have to move from temporary to destination. This is the temporary, right? Here to here we have to move. Sir, is it this instruction or not? Yes. So that this one will come here. Okay. Now just I am deleting here. This is the way how it is going to move, sir. Very simple. I think for 2 disks you got clarity. Same thing you can do for n disks. Sir, now I will run this code, okay, just by passing 1 disk as the input. Now just to check how it is going to work. I am passing for 1 disk. Is the disk 1 move from source to destination? Yes. Now I will change this to 2. Okay. Sir, now what will happen? First disk we are moving from source to temporary. Okay. Source to temporary. Then we are moving second disk from source to destination, and we are moving first disk from temporary to destination. Okay. Sir, if you are clear with this, I will take 3 disks and I will show the solution. Can you please confirm, is it clear up to this whatever I covered?
Yes, sir. Yes, sir.
Sir, in the when n is equal to 2, so when this towers, this third L in the else part, when 2 minus 1, it will print this, it will go to another line number 2, it will go from there.
Yeah, it will go to when we are executing 5th line, it will go to again first line and it will check what is the value of n. N is equal to 1. Then condition in the second line got satisfied, it will execute third line. Again, the control will come to the 6th line.
When n is equal to 1 means 2 minus 1, it will go to line number 2. So in that it will go to source to destination, but in the source in the source value is empty, and it's in the it will go from temporary to destination.
No. See, when n is equal to 1, don't follow this diagram. I think you have seen the diagram got changed here. Now imagine just for n is equal to 2, I am explaining the first step. Listen carefully. Okay, this is nothing but the second disk. This is nothing but the first disk. So here n is equal to 2, source is there, temporary is there, destination is there. So is n value is equal to 1? No. Then it is going to execute this one by passing n minus 1. Here n value is what? 1. And we are passing source as it is. Source. So destination we are changing. The parameters we are changing. And temporary will come here. Please listen these parameters. Now the control will go to the first one. So in this example, in this method call, n is nothing but 1. Source is nothing but same source. Sir, temp will become destination. Destination will become temp. Now what we are doing, we have to move the first disk from source to destination. In this method call, this is the source, this is the destination. That's why this first disk is moving from here to here. So method call got completed. It will come to this particular position. At this time, what will be the initial method calls? That only will be there. So now what will happen? We are going to move the disk 2 from source to destination. What is the source you have given? Source. So it will move the disk 2 from source to destination. What is the destination here? Destination only. So it will move from here to here. Next, this pending instruction is there. So it will call towers of an IE of n minus 1, that is 2 minus 1, 1. And then, sir, what is the temporary here? So we are going to pass a temporary, and we are going to pass source, and then we are going to pass destination. Now your source will become temporary. Your destination will become destination. Now what we are doing, we will move the disk 1. Already disk 1 is there in temporary. We have to move from temporary to destination. From here to here we will. Got it? I request everyone to please confirm. Is the concept is clear for everyone?
Whenever the
Yes, sir.
value is getting reduced, if we are putting if n is equal to 1, so that it will work in that manner, source to destination.
Yes. So I will run this for all possible ways. I have given input as a 1. Otherwise, you can give the dynamic value. Int of input, I will ask enter. So number of disks. Okay, number of disks. So here we are going to pass that n as the input. Now see. 1 disk means move 1 from source to destination. 2 disk means this is the process. 3 disks means like this. 4 disks means like this. So if I have 50 disks also there, you can move all the 50 disks also, no problem. It is taking more time because it is in the single digit only. It has to come to 2 digit. It may take some time. Okay, I interrupted. Now I will give the number of disks as a 1. So 2, okay, 3, so 4 and 5 and 6. Even for 7 we can see, even for 8 we can see, even for 9 we can see, 10 also we can. Somewhere that 10th disk movement will be there. You can see we are getting 7th disk movement. Okay, 5th disk. So 6th disk somewhere. Okay, maybe here somewhere you can see 10th disk movement. Maybe in the middle it will be there. You can check it later. Okay, these are nothing but what are the possible ways are there. I think the towers of Hanai problem and how this problem is going to work, it is very clear for you people. I think so. Can you please confirm? Is it clear? Just I will copy paste up to 6 digits or 5 digits. Sir, is it clear up to this, whatever we have covered?
Yes, sir.
Yes, sir.
So with this, the story of recursion got completed successfully. We finished this 7th chapter also. Sir, can you please confirm, have you enjoyed these sessions called recursion?
Yes, sir.
Now
Yes, sir.
you got idea about recursion, when we can use recursion, all these things you got some idea, right? Please respond.
Sir. Yes, sir.
Right. Now I will go for the next chapter. Maybe I will give some introduction. With that I will stop. Listen carefully. The next chapter what we have here is nothing but backtracking. A very important chapter, sir. Okay, and it's very simple. Nothing is there. Around some 2 main important problems we are going to discuss. What is this backtracking? Okay, first I will provide introduction to backtracking, sir. Sir, now I will give some real-time examples. Slowly, I will bring into the coding, sir. Sir, anywhere have you observed in the olden days? In the olden days, there will be a briefcase, sir. Okay, there will be a briefcase. For that briefcase, so do you know a number lock will be there? Okay, a number lock will be there. So you have to enter 3 numbers by sliding a number button will be there here. By sliding that, you have to select. Even nowadays also we are getting lockers like this. Okay, so you have to set the correct 3 pins, three digits we have to give. If you give correct digit, that lock will be unlocked. That means it will be opened. If you are giving wrong pattern, then what will happen? Immediately it won't open. That everyone knows. But my condition is, my requirement is, I got this briefcase. Assume in this briefcase we have 1 lakh amount is there. We need to open this briefcase. So this task is given for you. What you are going to do? So if the task is given to me, I will start with the first 0, 0, 0. Right? 0, 0, 0. If the lock is not opened, the next combination I will take 0, 0, 1. If it is not opened, I will take the next combination as a 0, 0, 2. Like this, I will try up to 0, 0, 9. The lock is not opened. Now my question for you people, can you please tell me what is the next combination that I am going to try? Please tell me.
100 or it's all the possibility.
So
Which is the
10.
010.
0, 1, 0. Is it correct?
Yes, sir.
Then 0, 1, 1. Is it correct? So 0,
Yes,
1.
sir.
You can see we can develop these kind of things around by using recursion. Okay. 900 possibilities. Is it correct? Maybe. Huh? Okay. Sir, here you can see this process we know, right? Recursively we can able to do that. But now my question is, sir, from 0 to how I got the values? 0, 1, 2 up to 9. Okay, sir. But again, I got a old value only. Means what? Something like again we will begin from the 0. Do you know? This concept is called as backtracking. This concept is called as backtracking. And one more example I will give. For example, consider I have A point is there, B point is there. I have to move from A to B. Okay. Assume here police people are there, or somewhere the road is blocked. You need to take another source. Sir, then I tried from here and I am keep on moving. The road is ended here. So I am not able to reach my destination. So what will happen? Can I come back? Again, I will start another path. Suppose consider here I got another path. This path is ending here. Sir, can I take this path? No, again come back. I will search for some other path. That path is going to take to the P. Now I will select this. Sir, directly we can't go like this. We can't imagine. We will try some other path. If your requirement is not satisfied, you can come back. This process is called as backtrack. The best example, still one more example I want to provide for you people. So that example is nothing but, do you know, you can see rat in mass. I will show you the images, you can see. Sir, maybe in your school days or maybe in the paper cuts, you can able to see these kind of things, sir, right? You can able to see these kind of things where a rat will be there. So some starting positions and some ending positions will be given. So you have to move from starting position to ending position. Like this, you have to move. Some diagrams are not clear. Okay, I will take this. Okay, or any other? Yeah, we will take this. Now you can see. Okay, like maybe assume here we have some starting position is there, ending position is there. So we have to move to the end. How it is coming? For example, consider this is the door. Sir, it is coming here, it is coming here, it is coming here, and it is coming here. Sir, this door got locked. Again, it will backtrack, right? So all possible combinations it is going to do. This is nothing but a best example for backtracking. Yes, you can see these kind of problems also we can solve, but it may take some time and we need to analyze very clearly. Okay, I think the theoretical point, I mean, by seeing the examples, at least you got some idea what is mean by backtracking. Sir, clear concept is clear?
Yes, sir.
Yes, please confirm everyone.
Sir.
Right. So here I can say, okay, I can say, do you know examples, number locks, okay, path finding, okay, Sudoku. These are some real-time examples for backtracking. Backtracking means what? So it is a method. It is a method by which a solution found by moving or by searching through, okay, by searching through large volume of data with some boundary conditions. We are going to move towards large volume of data. Okay, that process is there, right? That is called as backtracking. Okay, so there are so many examples are there for this backtracking. Already I covered number locks, rat in maze. Okay, next and after that n queens problem. Next and after that, do you know grid based problems? Okay, next and after that, Sudoku. So all these things will comes under these backtracking, sir. Okay, and there are three types of backtrackings are there. Types of backtracking. There are three types of backtracking are there. The first one is nothing but so decision. Okay, decision based problems will be there. Decision based problem means what? Sir, we are keep on moving into the backtracking. So I need to check whether solution is existed or not. Okay, solution is existed or not. Assume I have a grid is there like this. Okay, I have some grid is there like this. Assume this is nothing but okay, this is nothing but I have a grid. Just for example, I am telling this is nothing but a grid like this we have. And okay, and in this grid some open place is there, and here some open place is there. Okay, assume so here here what I'm going to do is, okay, yes, assume this is nothing but the problem what I have. Okay, this is nothing but the problem what I have, rat mass problem. Assume we have given a rat. Okay, so here rat is coming. So what is the first category is decision based problem. Array, in this particular problem, is there any possibility to reach to the destination? Sir, is there any possibility? If you see there is no possibility, so answer will be either yes or no. These kind of problems are called as what? Decision based problems. Now assume so here we have, okay, here we have open is there. Okay, and here we have open is there. Okay, and here we have open is there, and here it is closed. Okay, like this we have. Sir, there are many number of solutions are there. Have you observed? It can move from here to here, and it can come here, and it can go here, and it can reach. This is one solution. What is the second solution? It can come here, it can move here, and it can come here. This is second solution. There may be n number of solutions. Now I am talking about the third way. The third way is nothing but what? Enumeration based problems means what? Here we are going to get all possible solutions. there is one more thing from the diagram. If you see, sir, this rat, if this rat is intelligent rat, then what this rat is going to do is it will move from here to here. Sir, if this rat is intelligent, because shortest path, right? If he is traveling here, then what will happen? Time taking process. Have you observed? That is nothing but the second case. Second case is nothing but what? Optimized. Okay, optimized solution based problems. Optimized solution based problems. So here we are going to get only one solution, which is optimized. Okay, which is best. So these are nothing but three types of backtrackings what we have. Of course, we are not going to discuss about all these things. We will take some applications and how this backtracking is going to work. How this backtracking is going to work, I am going to explain. What are the applications is just for your understanding purpose. Backtracking with list I will explain first. Then we are going to solve n-queens problem, and then we are going to solve gridways problem, and then we are going to solve Sudoku problem. Okay, so today I will explain this backtracking with the list so that peacefully you can close the session by analyzing that backtracking working principle. Tomorrow, if you see the applications, you will get some idea how backtracking is working. The total core concept I am giving with this example. So in this n-queens and gridways and Sudoku problem, we are going to see actually this gridways is not related to the backtracking, but in the Sudoku we need to travel through the grids. That's why I'm explaining this. So this n-queens and Sudoku, we can imagine the problem and we can search for the solution. How the backtracking is working there we can't see. Okay, just we have to imagine. That's why a full-fledged backtracking example I'm going to take now so that you can understand very clearly how it is going to work. I request everyone to please confirm is the concept of backtracking. So is it clear for you people? Everyone please confirm. Please confirm.
Yes, sir.
Yes, sir.
Right. Now we will see how this backtracking is going to work with the help of a list. Very simple code, sir. Direct program is there. I will show you, but please concentrate well, because if you understand this, tomorrow class will become very easy for you. Okay. Sir, very simple program I am going to demonstrate. Around some 10 lines code will be there. Listen carefully. Sir, I have a list is there with me. The elements in the list are 0, 0, 0, 0, 0. How many elements are there? 5 elements are there. I will print the list so that what output I am expecting? 0, 0, 0, 0. Like we will get 5 zeros. Let me check. Let me check whether we are getting that 5 zeros. Yes. Now what I am going to do is I will write I will write a function called change, which will take a list and it will take index and it will take a value. What this particular bloody function is going to do is it will change the value of that particular index to with a given value. So I am calling change function by passing the list. Can you please change the value which is available at 0th location with value 1? Now, if you print this list, we are going to get 1, 0, 0, 0, 0. Because, sir, in 0th location, we are changing that particular value. So what will happen? We are getting 1, 0, 0. Sir, I will pass this one. Can you please keep on increasing this index value and fill this incremented value? Try to increase the index value by 1 unit and try to call by adding value plus 1. Keep on changing the value so that my expected output will become like this. How you can do, sir? Very simple. I am going to call recursive function by passing same list. I will add index plus 1 and I will add value plus 1. So that what will happen? Next time the function will be called. First time we called a function for list 0, 1. Next time the same function will be called for 1, 2. Next time the function will be called for 2, 3. Next time the function will be called for 3, 4. Next time the function will be called for 4, 5. So next time the function will be called for 5 comma 6. It is a never ending process. We will get error. But what is the length of the list? 5. So 1, 2, 3, 4, 5. Here itself we have to stop. Sir, when we can able to stop? If the index value is reached to the length, we can stop, right? So here I am checking the condition. Array boss, if your index is equal to the length of the list, okay, then just you can stop the process. That's all right. Now I will execute this code. Sir, are you seeing the change? Yes, perfectly. I think this change function, by using recursion, how I updated the value is very clear for you people. I think so. Can you please confirm, is the concept is clear up to this?
Yes, sir.
Please confirm, everyone. Sir, no response from chat window. Please confirm. Clear?
Yes, sir.
Because it is very difficult, sir. That's why I am trying to ask. Keep on. Please confirm.
Yes,
Now,
sir.
sir, I want to show you this diagram, how internally the stack is going to maintain. Because in this, I will add one small line, the output is going to change. That's why, please listen carefully. Internally, it will maintain a stack. Okay, internally, it will maintain a stack. So in that stack, in the first frame, we are calling a function by passing index value is equal to 0 and the value will become 1. This is the first method call. Then index value is not length. Then what will happen? So that value will be assigned and we are calling change function by passing. Next time your call will be for the same list. Your index value will become 1 and your value will become 2. Next time again one more recursive call will be there. These entries will be stored in the stack frame. So I is equal to 2. So that value will become 3. Next what will happen? Sir, I is equal to 3. That value will become 4. So next what will happen? So your I will become 4 and your value will become 5. Sir, up to this, okay. When you are calling next time, your I value will become 5. Sir, this condition satisfied, it will come out. That means this entry won't be there in the stack. This is nothing but what happened in this particular program. But sir, we have an option automatically. What our execution is going to do is, it is going to call back every time to destroy these values. It is going to call back like this. It will delete all the entries from the stack. This process is called as what? Somewhere in the beginning I told backtracking. Now I am going to do this backtracking job. So what is the backtracking job I am going to do is, please listen carefully, a small change. Sir, already I have a list. My list is having 1, 2, 3, 4, 5 values, right? And the indexes are 0, 1, 2, 3, 4. Now listen carefully. What I am going to do is, sir, when you are coming back, so from here to here it will come and from here to here it will come. When we are getting from here to here, sir, index value is equal to 4, right? That means I will write a small code. What is that code is, your L of index value is equal to, L of index value minus 2 I am taking. Okay. That means what? In this particular position, which element is there, from that we are going to subtract 2. Sir, here I value is what? 4. In fourth location, what element is there? 5. 5 minus 2 means 3. Then it will come here. Okay, sorry. I is equal to 4 got executed. One second. Yes. So this, when it is coming from here to here, this operation got completed. And when it is coming to here, I is equal to 3, right? So what will happen? L of 3 is equal to L of 3 minus 2. 4 minus 2 will become 2. And from here to here, if it is coming, I value is equal to 2. L of 2 is nothing but 3. 3 minus 2 will become 1. And when it is coming to here, I is equal to 1. So in first location, we have 2. 2 minus 2 will become 0. So from here to here, it is ending means I is equal to 0. L of 0 is 1. 1 minus 2 will become minus 1. Sir, while doing this, it is going to delete all these entries. So if I am telling this for you people, okay, you people may have a doubt. Array, you are telling wrong answer, sir. Really, is it happening in the background or not? So
Sir,
until you are going to, sir,
Sir, the last part, L of I minus 2 or L of I minus 1?
I think, sir, L of I minus 1.
no, L of I minus 2 only. 5 minus 2, sir, see value here. Sir, I am not reducing the index. Listen carefully, I am not touching the index and the values because these indexes are already available. I don't have any permission to change it. While coming back, I can get that index. Index is equal to 4 means L of 4. My array is there. So in that fourth location, which element is there? 5 is there. From that, I am subtracting 2. So that value will be updated to 3. I am not talking about index. I will get the index. I will update the value available in that index. I am not changing the value. These values will be automatically deleted. Automatically, it will come back. I am not required to do any modification.
But value should be 4, sir, right? Because next we will come to index 3. So value should be 4, right? 5 minus 1, if you do, then it will be 4.
5 minus?
Sir, value should be 4. If at L of I is equal to 4, value is 5. So at L of I is equal to 3, value should be 4, right?
Sir, L of I value is 4 means L of 4. What is the value available in L of 4? Previously?
5.
Minus which value we are subtracting from this formula?
2.
What is the updated value?
3, sir.
Where it will be updated? Are
At
you
I
seeing here? L of 4. So I am trying to do modification in this location. So while doing recursion, I modified with some values. While coming backtracking, I am trying to do some other modification. So I am showing backtracking is working. Like that, I am going to show you a proof. So these values is keep on increasing at the time of adding. At the time of backtracking, I am subtracting with -2 just to change the output. Got it?
Okay, sir.
Sir, I request everyone to please confirm. Is my concept is clear for you people?
Yes, sir.
Yes. So where you have to add this formula backtracking. That means if all these tasks
Sir,
are got completed.
Sir,
Hmm.
in this, if we have a 6 means if we have a length is 5, and if we have if a length is 6, then same it will be L of I minus 3.
One more entry will be there here. From
Means-
that also this formula will work. -2 it will check. This value is fixed, sir.
-2.
Yeah, just for example sake, I am telling you, you can take anything.
No, my question was that if the value would be if the length is 6, so that L of I minus would be 3. That this -2.
Sir, now I'm not getting your question. You are talking about L of I is equal to L of I minus 2. You are talking about that formula?
Yeah, that.
Why that formula is depending on the length? I have written I. I means index. Index can be anything. If length is 100 also, no problem. Every element we are subtracting with -2.
Okay.
Okay. Right. 1 second.
Sir, but what are we achieving after reducing the values by subtraction?
Sir, what is your question?
Sir, what are we achieving by reducing the values when we are back?
I'm explaining backtracking is working. If you see this backtracking is working.
Free the memory. It is to free the memory.
While no. It is going, sir, who is going to free the memory? When you are calling the recursion from bottom to top, so it is calling recursion. Some value will be updated. It is going to delete automatically. While deleting these, if that values also get deleted, what is the use of recursion? The data will be there. I am telling the corresponding entries that method calls will be there, right? Those will be deleted after completion of recursion. Okay. Now I'm going to take L of index is equal to, so L of index minus 2, sir. Now observe carefully. I am calling this one as recursion and this one as backtracking. So recursion is doing some operation, backtracking is doing some operation. If everything is correct, whatever I explained, my expected output is what? -1, 0, 1, 2, 3. If I am not wrong, you can able to see we will get the same output. As you can see, -1, 0, 1, 2, 3. Sir, I displayed output in this position at the beginning. My beginning, what is the value while starting from here? While starting from here, what is my output? Sir, we got all zeros, 0, 0, 0, something like this. We got all zeros, 0, 0, 0, 0, 0. So we are keep on doing some modification, and while backtracking is going on, I am doing some modification so that my final output is -1, 0, 1, 2, 3. Can you please show me in this particular point, what is the output? So what is the output? 1, 2, 3, 4, 5, right? But you can't say, I mean, we can't print these values from the main program, because first we are responsible to call this method. This method is internally calling this method. Once if all these methods got completed, in the backtracking, it is doing this process. So at the end only we can get the fruit. But in the middle, if you want to see, have you observed when the recursion is going to terminate, when this plate is going to end, we have written some base case, right? At the time of base case execution, if you print the list, you will get that updated. Here I am going to print the list. In this case, you can see we are getting 1, 2, 3, 4, 5. If you want, you can see. Sir, this is before calling the recursion. This is after execution of recursion. And this is after backtracking. I think with this example, you got very clear clarity how the backtracking is going to be happen. So we are moving from one position to another position by keep on doing the changes in the list. Once if you reach destination, definitely again you have to come to your native place. While coming, so you are not coming alone. If you are coming alone without doing anything, then it is called as recursion. So when you are coming, what you are doing, whatever list you have, you are keep on updating, so that what will happen at the end, you are going to get the updated list. So backtracking, while coming back, you are doing something. So that we have to concentrate in this chapter called backtracking. I think everyone got clarity about how this backtracking is going to work. Clear?
Sir, in this first the recursion will be completed and the base condition need to be satisfied, and then only the backtracking will.
Yes, exactly. When seventh line will execute. So after executing all the recursive calls, at the end, it will start executing backtracking. In the previous examples, somewhere in the recursion, I told how many times recursive calls are done, those many times that seventh line will execute, because it is depending on that stack frames. Got it? Right. I request everyone to please confirm. Sir, please confirm. Clear?
And this are the formula related, that this formula is -2 is.
No. You can write anything. Just for example sake, I have taken -2.
Okay.
Clear up to this, please confirm.
Yes, sir.
Yes, sir.
While doing backtracking also, we can do dynamic subtraction. Yeah, we can do dynamic subtraction. Yeah, we can do. So with this, I am going to wind up today's session. Sir, tomorrow we are going to talk about, okay, tomorrow we are going to talk about these three problems. So n-queens, grid based, and then Sudoku. Actually, n-queens and Sudoku, these two are nothing but backtracking based problems. But in the Sudoku, we need some small application. That's why we are talking about the grid base. Okay. So with this, that backtracking will be completed. After backtracking, I'm planning to give that what you can call dynamic programming also. Okay. After that, you can expect some string programs, sorting, searchings. Okay. Then linked list like that. Okay. And we have some complete syllabus is there. Let me copy paste that syllabus. These are nothing but the topics which we are going to discuss. So in this, we are at backtracking. Okay. Dynamic programming. After that, string, then sorting and searching applications, divide and conquer algorithms, linked list, stacks, queues, hash table, so tree, priority queues, and graphs. Maybe one or two topics I may add, but tentatively this is the fixed now. Okay, right. Anyway, remaining things we will continue tomorrow. I will upload the running notes within few minutes. You can download. Okay. Thank you, friends. Tomorrow, as usual, we have class from sorry, 1 second. Sir, tomorrow there is no class, or we will plan for the tomorrow class is there or not. I will update tomorrow morning, sir, in the WhatsApp group. I will update tomorrow morning in the WhatsApp group. Okay.
Sir,
Sure.
sir. One.
Yes.
That
If anyone is not there in WhatsApp group, please send a message again. Today night I will add it. Okay. 7386237319. If anyone is not there, please send the message. Okay. Yeah, right. So tomorrow class is there or not, I will inform you tomorrow morning. Okay. So remaining things we will continue tomorrow or
Sir-
day after tomorrow. Okay.
Sir, one Python question regarding.
Yeah.
So that implicit concatenation, how that happens means the space, if we have two string and with that space directly concatenate, how it works.
No, I'm not getting your question. Can you please
Sir,
repeat?
if I
One
have
second, 1 second. Sir, that's all about today's class. The people, those who want to listen, one doubt is there from our student. If you want to listen, you can listen. Otherwise, you can leave the meeting. No issues. With this, our topic got completed. Okay. Badrinath, you have to send to message to me. Okay. I can't add you. First, send your information to this number. I will add you. Yeah. Tell me, sir, what is your doubt? Can
Sir,
you please write the code?
if A is equal to
Hmm.
any Prakash and space,
Hmm.
complete that string,
Hmm.
Sir, and space
Hmm.
and Babu, and in with another it works and it work if
Easy.
we are printing, so without plus it's directly concatenating. That I didn't understand it.
Really? Oh.
Yes. So in the string,
Maybe
in
it
the
is taking the complete string.
yes. So
It is taking complete string. Yeah, maybe I will check this, sir, because I have seen first time this problem. But what is your question?
means how implicit it is concatenating that two string with the
Mhm.
within the space. So
Hmm.
I in the string we know that we for concatenation we need two string, and the plus operator with plus operator we can concatenate that. But
Yes,
how
yes.
this space internally how it is concatenating, that I didn't understand that.
Yeah,
I
maybe I
just
will
want-
check, sir. Really, I too don't know about this solution, but I will come back with a solution. But maybe I'm thinking that this entire thing will be treated as a string. So
Yes.
whatever we have given here, it is going to perform some trimming operation. So I think these are not two strings, sir. It is a single string. Inside this, we have taken some string.
Mm,
In that manner, it is going to take. Maybe it is going to trim these spaces automatically, or otherwise I will do one thing. So this is 0th location, first location, second, third, fourth, fifth, sixth. This is 7th location, right? Let us print a of 7. What we are going to get? We are getting b. That means it is adding. So I think it is removing this. Let us give two spaces. What will happen? Yeah, it is removing automatically the spaces. Without spaces, if you give, then we are getting like this. So maybe it is treating like empty string, sir. Or if you have any spaces, it is going to remove. Or we will take any other, we are going to get error if you take any other character. So I will check, sir. I will check and I will get back. Okay.
And one thing, sir. Last question. If we have a list,
Hmm.
1, 2, 3, and if we are using in the print function, I am using print l dot remove x. So that directly it's giving none. So that I means how it I didn't understand.
It is returning none. The return type is none for the remove function. I think so. It is going to remove that object. Okay. So before we have 1, 2, 3, after we have 1, 3, but the return type is none. Return type is none.
If we will remove the print statement and l dot remove only, then we will get an output. After
No,
that,
no. If you perform with print or without print, your output will be same. Okay.
no,
So
sir.
without print function also, you can call remove dot to.
Yes, yes. But why that none? I didn't understand. When you are using
Maybe easy. Suppose if you are taking the element which is not available in the list, maybe it is giving something like no, it is also returning none. Maybe the return type is none, sir, because see, there is one concept is there in functions. So if you are taking any function and if you are printing some message, okay, and if you are calling the function, that method will execute, right? You know this concept, right?
yes.
So here, if you are trying to print in this particular, then you are going to get none, because the default return type for a function is nothing but none. If a
Yes,
function
yes.
is not returning any value, by default it will take none. Maybe in that aspect it is printing none, but really that remove function is not having any return type. Okay.
But when, sir, we are using pop method, it returns something, right?
Maybe pop method is going to return something. Pop method, that element which is removed, it is going to return, I think so. Let me check. Pop of 0. Yeah, it is going to remove the element. I mean, which element it is removed, it is returning, because here you have given the input as index value. That's why in that index, which element it is removed, it is returning. In the case of remove function, you have only input, output is not there, right? Because
Yeah.
if you are asking for deleting the element called 2, so what you are expecting, that element should be deleted in the list. It won't return a new list, because list is modifiable. You will get a
Yes.
new list by default. But if you ask a pop, there is a chance. If you give 0th location, I want to remove the element which is available in 0th location, maybe for you it is returning that element which is deleted. So these kind of things we are going to use it in stack, all these things. That's why, so there is a specific implementation like this.
I thought that print is also one function and we are calling another function, and that's why it is giving none.
No. Print is a function only. So
Yes.
some functions, if you are calling in the program, if they have mentioned return type, it will return that value. If they have not mentioned any return, then it is going to return none value.
Okay.
That is the default nature.
So it's depend on that functionality how it works. Means that if it has a property of returning value, then it
Then
will
you
give
have to
return.
return.
Otherwise,
Yes.
it will give none.
Yes, that is a problem with the Python, sir. In the remaining programming languages like C or C++ or Java, compulsory you have to tell the return type, whether you are returning an integer value or whether you are returning floating point value. Like that, you have to mention. If there is no return type, that is mentioned with void. If you are writing void, then you are not required to write any return statement. Even if you are trying to print within some print statement, it will raise an error, because that function is not giving any value, but you are trying to catch it. Like that, it is going to give error. But here, the such type of functionality is return type is not there. First of all, data types concept is not there, right? That is the way we are getting these small problems. Okay, but those
Okay.
are ignorable.
Okay, sir. That's fine. Thank you, sir.
Right, sir. Thank you. Yeah, thank you, guys. Good night. Bye.
Good night.
Thank you, sir.
Bye, sir.